So it's a real pleasure to start today's scientific session with our first invited talk. Our speaker, Sabrina Ricci, is a highly experienced professional in the space sector with nearly 30 years of expertise and background in political science. She spent more than 2 decades at the Italian Space Agency, where she held key positions related to Earth observation, education, human resources, and outreach. Today, she works at Solenix Engineering and serves as AI ecosystem coordinator at the ESA field lab within ESA's Earth Observation Directorate in Frascati, Italy. In this role, she leads the development of the AI ecosystem, fostering the integration of digital technologies to enhance the impact of Earth observation. Sabrina has played a central role in building strategic partnerships and innovation networks that support PhilLab's mission, driving disruptive and transformative innovation in the use of AI for Earth observation. So before we begin, I would like to express our sincere sympathy for the difficult situation she and her family are going through. We truly appreciate her kindness and commitment in keeping her talk online despite these circumstances, and we wish her family all the best. Please join me in welcoming Sabrina Ricci, who will talk us about From Observation to Action, how ESA PhilLab shapes the future of Earth with AI.
So, good morning. Good morning, everyone. I thank you, first of all, for the nice words to welcome me. I'm really sorry that I cannot join you in person. I'm confident I will come soon to visit you. And in the meantime, I really wanted to be here, even if from remote, to give you a few information about us, about the PhilLab, about our activities with AI, and to hoping to start something for a real follow-up with your community on Earth observation and on AI. So as you were saying, yes, today I will give you a talk about what we do at the PhilLab, from observation to action, how ESA PhilLab shapes the future of Earth with AI. Before introducing the talk, I would like to say a few words about myself. Well, actually, you already said most of it. Just wanted to share with you that since the beginning that I've been working in space domain, I've never changed this domain. It's almost 30 years. I passed from private industry to governmental agency. I've been working at the Italian Space Agency for more than 20 years, and now through Solenix Engineering, I'm again, and finally, I landed at the European Space Agency because my passion has always triggered my job and my activities, and that is why I'm here today to try to arise awareness inside the community about the true potential of space activities for all of humanity and for the benefit of our planet. So first, a few words about the European Space Agency. We are an intergovernmental agency with different premises around Europe, the headquarters in Paris, and then other premises also in Spain, as you know. What we do is promoting cooperation among European states in space research, technology, and applications for exclusively peaceful purpose. What we do is work together with our member states for the future of space in general. We are today 23 member states, 3 associate members, and more agreements with other countries also outside Europe with whom we have cooperation agreements. I would have brought 2 videos to introduce in a more captivating ways the European Space Agency and Earth observation to you. I will try to make it work. Please stop me if it doesn't work. Let's see.
This is the European Space Agency, dedicated to the peaceful exploration and use of space for the benefit of humankind. Established in 1975, we work together with our 22 member states to push the frontiers of science and technology and promote economic growth in Europe. We have offices in 8 locations across Europe and 1 at Europe's spaceport in French Guiana, where we provide independent access to space for scientific and commercial missions. Exploring space is humankind's greatest adventure and one that we have been involved with for more than 40 years. ESA has the technology and expertise to keep Europe at the heart of the new age of space exploration. From low Earth orbit, we are working to bring humans back to the Moon and then onto Mars. By expanding the frontiers of knowledge, we are helping to answer the big questions about the universe. Space provides us with incredible opportunities to experiment and discover, yielding amazing new science. From Earth's neighbors to new worlds, we study stars, galaxies, and look for exoplanets. In addition to astronomy, planetary science, and astrophysics, ESA scientists work on growing food in space, searching for life on Mars, and understanding our own planet. From space, satellites are watching over Earth to monitor its health. Our satellites improve weather forecasts, observe the long-term effects of climate change, and contribute valuable knowledge to Earth science. The Sentinel satellites for the European Copernicus program provide vital information on our environment that can help improve our daily lives. Satellites also help you find where you are and get you where you want to go. We have developed Galileo, Europe's own global satellite system for navigating the globe. With over 20 satellites and a network of ground stations, Galileo provides precise global positioning information. Satellites are also connecting the world, making possible many of the technologies we use every day, like satellite TV and internet access. ESA is at the heart of Europe's satellite communications, developing new telecommunication systems and nurturing European innovation, bringing industry, science, and space technology together. In order to achieve all this, we need pioneering technologies that push the boundaries of the possible. ESA's world-class laboratories turn science into innovation, developing hardware and software for use in space and on the ground. Space technology gets rigorously tested to ensure it can withstand the harsh environment of space and the journey to get there. Traveling to space reliably is at the heart of ESA's vision for space transportation. We launch rockets that carry satellites into orbit and are constantly improving the design of our next generation of launchers, Ariane 6 and Vega C. These rockets and the reusable Space Rider will ensure that Europe continues to have autonomous and affordable access to space. Once in space, mission controllers are operating spacecraft around the clock to watch our planet, study the universe, and explore the solar system. We've flown more than 80 missions, including Rosetta, which landed Philae on Comet 67P, and Huygens, which touched down on Saturn's moon. We operate a worldwide network of ground stations to keep in contact with missions anywhere. ESA is dedicated to making space safer. Our teams help spacecraft to avoid collisions with space debris, and we are developing new techniques to deorbit dead satellites. We bring high-tech telescopes to scan the night sky for asteroids and missions to monitor our sun. With these technologies, early warnings can be delivered about potential asteroid impacts or hazardous solar activity that can affect infrastructure on Earth. ESA's diverse activities are all part of a clear vision for Europe in space. Space is the future, and through ESA, we are all part of it. This is ESA.
Okay, so I hope you could enjoy it. And if so, now just another video to go deeper in Earth observation and introduce my real presentation on the field. Sorry. Okay, yeah, so let's start from that. Let's start from this impressive video that I really love and I really see as an inspiration for what we do every day, because we are all facing the consequences of a rapidly changing world. But thanks to the satellite era, we are better placed to understand the complexity of our planet and really which are the actions needed to do something, to act with respect to a global change. Today, satellites are used to do every activity of forecast, of provisions for our planet. What we do is really taking the pulse of our planet, trying to understand every day how the vital parameters of our planet go. So forecast the weather, answering important Earth science questions, and providing essential information to improve everyday activities with respect to agriculture, to maritime safety, with respect to disaster, strikes, and the satellite data are more and more playing a vital role in doing this. in act, so not only observe, but act for the future and the benefits of our planet. How we do that? Through our Earth Observation Directorate in Italy, in Frascati. We have 3 main lines of activities: Earth Science, Copernicus, and Meteorology, with a number of missions and satellites in orbit. If we refer to Copernicus, we know is the Earth observation component of the European Union's space program. The initiative is led by the European Commission in partnership with us, with the European Space Agency. ESA is responsible for coordinating the delivery of data from more than 30 satellites. To meet the specific operational needs of Copernicus, ESA developed a completely new family of satellites, the well-known, I'm sure you are aware of that, Sentinels. And today we have in orbit 2 complete 2 satellites constellations, Sentinel-2 and Sentinel-3, already in orbit, along with the 2 additional single satellites, Sentinel-5P, and Sentinel-6. And now that we just launched the Sentinel-2 to restore the Sentinel-1 constellation, we can count a total of 11 Copernicus satellites currently operating in orbit. What does this mean? This means that we have an incredible affluence of global data coming from satellites, but also from ground-based, airborne, and seaborne measurement systems. Combined together, this data provide continuous information that helps service providers, public authorities, internal organizations, all the actors of the community to improve, who act to improve the quality of life for citizens in Europe and beyond Europe. So, what's particularly remarkable for the Copernicus mission and for the satellite data coming from our Sentinels is that all the Copernicus data and services are free, are openly accessible to everyone. Copernicus supports a wide variety of applications, including climate change, monitoring land and coastal monitoring, temperature, wildfire observation, agriculture, and the monitoring of disaster like earthquakes, volcanoes, and so on. Also air pollution, and we just have to keep in mind every day that through Copernicus okay, I'm sorry, I'm just passing from one slide to another. I hope that it works. Well, I'm sorry. Okay. We are here. So what we do, the big information and message is that we receive from our family of Sentinels thousands of terabytes of data every day. And the challenge for all of us is to interpret and to pass the right and useful messages from raw data to the community and people who need to work on that. And so finally, here we are to the ESA Lab, and triggered from all that I just said and building on the foundation led by the Copernicus mission, let me introduce you to our ESA Lab. The PhilLab is a division inside the Climate Action, Sustainability and Science Department inside the Directorate of Earth Observation Program. And what our message is that we strongly believe in truly transformative ideas who can have the power to transform Earth observation. The biggest challenge that we have is to make the most from the vast stream of Earth observation data, and it is from there where the PhilLab acts to connect cutting-edge technologies like artificial intelligence, but not only, as we'll see, to unlock the full potential of this data for innovative applications and insight. So, it's true that technologies like AI, like quantum computing, and other emerging fields are not just incremental advances, but they really represent and can represent a transformative innovation for Earth observation. And that's the reason why back in 2018, the former the present Director General of ESA, Josef Aschbacher, decided to build this open lab, this innovation lab, to really go and pass from Earth observation to Earth action and make the satellite data real actionable information for the use of everyone who can play a key role in the future of Earth observation and our planet. These technologies, these disruptive technologies, if applied to space, but in particular to Earth observation, they really can change the way we explore space, the way we observe Earth, and ultimately they can help us to understand and protect our planet. This is our mission, to raise awareness on this, because for maybe too many years, these two apparently distant worlds, digital technologies, transformation with digital technologies, application of AI, was too distant from space and Earth observation. We know that in other domains like medical, for instance, the AI is very used and applied already since many years. Now our mission is to let the community understand that these worlds are not so distant as they seemed. So what is the PhilLab and how it works? It's the lab where we really explore and apply transformative technology to Earth observation, and we do that through our two offices, the Explore office and the Invest office, where in a real pipeline, virtuous pipeline, we try to go from the discovery of blue sky ideas, the exploration of these ideas, the nurturing, the research on that to understand if they can really be helpful. We try to develop new kind of applications of these technologies to Earth observation to address some of the greatest challenges that humanity faces, and also try to strengthen and to support the European commercial competitiveness, because what we also do is to encourage the commercial actors, so industries, the industrial world, to explore how the use of digital technologies on Earth observation can boost the space economy and can arrive to new and helpful solutions. So we face all the challenges that we mentioned, from the effects of climate change to any other well-known challenges of the humanity, to try to issue new solutions. So we try to identify new business models in space. We try to identify new research results to deliver better solutions, better products and services to the communities worldwide. What we do at the PhilLab is embracing a real thinking out of the box. We brainstorm together, and later I will tell you how. We are a real open lab, so we welcome new ideas and we brainstorm together to understand if these new ideas can be a booster for Earth observation and can accelerate the use of satellite data. We can fail. At the PhilLab is one of the fewest places where in ESA where you can fail, because from there you really can understand how to continue. Okay, I hope now you see the slide on the location. It should be that. If you can give me just a confirmation that you see the ESA PhilLab location and people. Yes. Do you? Okay. Oh, okay. All right. Yeah, here we are. So we're based in Frascati, as I was saying, established in 2018, and we are an open lab. That means that we host every day. We have a very high turnover of people because we host visiting researchers, we host members coming from the scientific and academic community, but also from commercial communities. We have been, in the last 4 years, we have hosted more than 26 nationalities, more than 120 people who came and worked with us for a while to explore these possible application of digital technologies. So we have these different schemes to work together. We have a scheme for visiting professors, we have a scheme for visiting researchers, industrial and scientific, meaning coming from industry or from academia. And in a very simple way, I will tell you later, we just exchange common research ideas, and we host PhD students or postdoc young researchers to work together on a specific research topic for a while. We also have a scheme for internal ESA research fellowship, and I will tell you more just in a minute, because now we have open position. We co-fund a PhD from all over Europe to work together, and we have other internal scheme for younger students, like a young graduate traineeship, internship, and national training. As I was saying, at the moment we have vacancies that you can find on our ESA career job page. Here it is written that they are expiring the 21st of October, but they will be extended. So in case from the audience that unfortunately I cannot see, is there anyone interested, please, you are welcome to apply. These are vacancies for internal ESA postdoc. So you must have a PhD, and they are on specific topics. There will be more on other topics because we really try to create a cohort of experts or future experts of this new era of technologies. So now we see something on AI for EO, for climate, you see quantum computing and so on. So please go and check if any of these positions can be of interest for you. And also we have other opportunities to work together. As I said, this exchange of ideas and projects, so with no exchange of funds, you can join the PhilLab just to propose ideas and projects of research. And also we have many other opportunities that we launch periodically to work together, like ITT on the typical ESA STARS portal, or other challenges, hackathons, I will see a bit more later, or the commercial co-funded program that we manage inside the PhilLab, Incube the program. I will say something more later today. But just to say, please feel free to reach out. I'm sorry that I cannot be there to network with everyone, but I'm here open to the networking, really. So let's do that, because at the PhilLab we really work together. Also, now I don't think that there is still something open, but periodically we launch challenges. We have these hackathons continuously open, like also the FIA ideas and so on. So keep an eye on our website, because we really encourage any collaboration to go on and explore what we do together. To conclude the collaboration encouragement, please feel free to make a picture or to scan this QR code. I don't know if you can do it through the screen. I hope so. Otherwise, I am totally available for future follow-ups. We have this collaborative innovation network. They are partners working for us and with us to scout talents from academia, from industrial, from professors who want to collaborate with us in every way. So also go and check the CHIN from ESA PhilLab. We have a huge ecosystem. This is really a very small portion of all the entities that we work with. They go from universities to research centers to industries inside Europe, inside member states, but not only. We are really open also worldwide. And now let's try to give more details on what we do at the Explore office, because as I mentioned it before, we are divided into offices, and our activities are structured around these two offices, these two main pillars. The first one, the one managed by the Explore office, is where we focus on Earth observation, sensor revolution, this digital revolution in which we really believe, and the new opportunities that the connection and processing of this digital revolution with Earth observation can induce. The other pillar is what is managed by the Invest Office, which really it's a continuous pipeline inside the PhilLab, and is how we invest in this research and this exploration that we do at the Explore Office side to support the development and commercialization inside Earth observation. So how we can boost also space economy with the innovative Earth observation products and services. Let's stay inside the Explore Office for now. At the inside the Explore Office, we concentrate, we focus on three main axes: artificial intelligence and machine learning, quantum and edge computing, and then IoT, blockchain, Web3, cognitive space, which is not a residual, but a parallel axis that we really are exploring and we really like to continue to exploring. And we explore these technologies to reshape the future of Earth observation, considering these technologies not just tools, but really considering them like enablers of innovation, which can help us to discover new ways to extract knowledge from space data and turn it into meaningful applications for the planet. We do it across the entire value chain, as you can see, from upstream to downstream, developing end-to-end systems and innovative business models that make this transformation possible. We do it, I shrinked a little bit my presentation, considering that it is online and I was really not sure how it worked. But now I wanted to give you real examples of what we reached. So I talked a lot about exploration, about research. I encouraged, I hope, to explore more also from your side on what we do. But we arrive to results, to real results, to results that you can touch. So I want to tell you more about a few of these real results that we had and that we are still having. And first I want to mention the FISAT mission. A few years ago, we experimented for the first time as a real test the FISAT-1 mission. For the first time, we put on board AI, a chip, you can see the Myriad 2 chip, which is an AI chip that was placed on board, and the FISAT-1 was launched to perform cloud masking, to identify the cloud locations and try to solve this cloud problem for when sending down to the ground the satellite data. So this was the first experiment to put AI on board and to put closer the brain to the eye. So we see things with the satellite. And what we do, putting AI on board, is trying to understand better the images, the data, the information that we have, and sending down to the ground information already more useful. So not just raw data, not just burden the ground station and the users on ground to put the burden to interpret and clean this data. What we're trying to do with the AI on board and what we're exploring, and it is working very well, is how we can do it starting on board. So we started with the FISAT-1, and it really is working very well. The chip on board and the information that we receive. And we launched last September, we're continuing this, we launched last September FISAT-2, which is a support for Copernicus missions and marks a significant milestone in our AI strategy, because with the FISAT-2 that now is in orbit, we are using it, so always with this AI on board, for maritime pollution detection, wildfire monitoring, and disaster management. So really, the FISAT-2, the AI on board, and this experiment that we are doing and that they are working, I repeat, very well, we really try to support the entire Copernicus mission to expand it and give it more hints to interpret and use the data. So the experiments are doing very well, and all this encouraged us to go on with this exploration that we are doing. Here you can see how also through our works, this is an example of a scientific paper that we published together with partners to underline and highlight how strong the cognitive cloud computing in space is for Earth observation, because really in Europe we are precursors for that. So we started to work on what is called cognitive cloud computing in space, 3CS, which is a new way of considering the satellites in orbit. What we're aiming to is to create a new fleet of agentic satellites. I don't know if you can see in the small picture the differences between the two. Maybe I have it here. Yeah, here you can see it better. The traditional bandpipe model with ground intelligence, how it's always worked. The difference with the cognitive cloud computing in space, which we call space intelligence. I go back again to tell you what is the 3CS. 3CS, because it's cognitive cloud compute in space, refers to the real integration of AI on computing, novel the computing paradigms, so using edge computing, using cloud computing, and the computing hardware inside space infrastructure to enhance what? To enhance the autonomy, the agility, the reconfigurability. Because, okay, I rehearsed on this word, reconfigurability, because it's important. The agility to act, to really have a connected space infrastructure with the computing capabilities. Imagine to have all the ability that you have on your computer up on satellites. Imagine how this can change, really, the future of Earth observation, how this can transform it, how this connection can really give quickly, very quickly, information, usable, actionable information. Also for early alert system, we assist wherever in Europe, worldwide, very too often to disaster when we arrive too late. We arrive when we can only understand, okay, what we have now, which is the difference on the ground. But what if we can arrive in time for disasters, for maritime surveillance? What if we can have real actionable data to act on time? It's going to be a real difference. I cannot see you, but I hope you are nodding, because I really feel it, and I hope I can transfer this to you. Now, here, staying in this, which are the projects that we developed also for the benefits, overall benefits of the planet and humanity, only by using, only is in, brackets, by using AI on EO. I wanted to mention this project that we had in collaboration with UNICEF for SDGs, for Sustainable Development Goals, and we also won. We were among the Globe Top 100 best project for SDGs. We had a prize from UNESCO. We have been awarded for the best uni for research, but I'm not telling that to brag about the prizes, but for tell you how, with the help of AI, we were able to respond to a need and a problem that UNICEF presented to us. In fact, UNICEF contacted us because they wanted to detect the dengue. So it's for health purposes, the spread of the dengue into particular areas, which were Brazil, the first one, and Peru, the second one. And they asked for help to understand, because they couldn't come up with a real solution to understand why the epidemic, the dengue, was spreading in particular in some regions and not in others. So what we did was a combination of all useful data, satellite data, data from on-site data, meteorological data, data about population, spreading of population, and so on. So very different data, and we combined them and calibrated them through AI algorithms to arrive to results useful for UNICEF to address these problems and these challenges. So this is what we want to do. We also have collaboration with the Save the Children and with other organization, because we are really confident and we are sure that we can do, we can help with the use of AI for Earth observation. Another place where we are experimented the use of AI through a platform that we give is on the Destination Earth project. I don't know if you are familiar with it. Destination Earth or Destiny is a flagship initiative of the European Union, launched in 2022 with a very, very high and ambitious purpose. The purpose to build a highly accurate digital twin of our planet, starting with portion of it. So digital twin for what? With which ambitious goal? The goal to monitor, simulate, and predict with high precision the interaction between natural phenomena, human activity, and the ecosystem of Earth. And this is what we did in a small, very smaller portion, for instance, with the UNICEF project. Because, okay, we didn't create a digital twin of area in Brazil or Peru, but what we did is correlate and calibrate their interaction among very different parameters. What if we can have a what if scenario with a digital twin? What if we can test first the reaction of a population, of a land to simulated events? This is the purpose of the project in general. ESA is collaborating naturally with the European Commission, with the ECMWF and UMETSAT, and we are really a group willing to work together for the same purpose. So we really use innovative Earth system models. We have platforms where we are testing the use of AI, the cutting edge computing, satellite data, and machine learning. If we are, well, we are confident, I mean, there is a lot of work to do still, but in the future, continuing on this, so going from observation through models to predict and so on, we're confident that with this we will allow the users of the models to explore the effect of climate change on different components of the Earth systems. So that's to say that we are going on, we don't stop. I mean, the Phi Lab as an innovation lab starts back in 2018, but we're really advancing on innovation strategy and path. We are, because what we understand, and we understand it every day, that nowadays we are all experiencing a profound technological transformation. And I'm sure that during this AI week that you are living and that you are really experiencing, you see that artificial intelligence is rapidly reshaping how we interact with everything and also with data. It is a software revolution. It's already, you know, this is a fact. And what we do is not stopping there. So what, on the other side, we try to explore also the hardware revolution. I'm referring now to the quantum computing because really, especially in this past years, maybe month, we are really on that. It's still the quantum computing is still a question mark in every domain, and maybe for us even more. But we're receiving very good signals from that. So what we do here in the slide, we call it the triple revolution. Space data, Earth action is where we start from, okay? If we go back to my first slide, it's where I started, it's where we start. Earth action, AI from one side, the software revolution, hardware revolution, quantum computing on the other side. So all these together, combined together, can really enable us to perform tasks that are fundamentally beyond the reach of classical computers. Together, they are forming, and what we are studying is exactly this, they are forming an extremely powerful alliance, an alliance that can change the way we observe and understand our planet. So you see in the middle, you see Earth action in the middle, okay, where these technologies meet to serve, for instance, one or humanity's most urgent needs, okay, monitoring and protecting our environment. On the left, AI, I said it, AI revolution, transforming how we interpret satellite data, automating insights, uncovering patterns that we couldn't see before, and we do it together. On the right, quantum revolution. As I said, unlocking entirely new capabilities, solving complex problems, optimizing models, accelerating calculation in the ways never before possible. In ESA, now we have in ESA, in Frascati, NHPC, and a lot of our researchers, our postdoc, now are working with the support of that by exploring how the HPC can use it. And we acquired already, I guess, so we are having inside the PhilLab a quantum computer to really boost this research. What we expect, this is the big question, because there is a convergence. We are exploring this convergence. What we do expect? We expect speed to perform a specific calculation much faster than the classical computers, accuracy to perform simulations of a complex system with a much higher degree of accuracy and efficiency to reduce computational costs and environmental impact. And most importantly, new opportunities to tackle global challenges in climate, disaster response, agriculture, and beyond. And if you ask me, where are we? Well, right now, we are at real critical intersections. So we are building hybrid quantum models where classical AI and quantum computing work hand in hand. And we are experimenting, we are observing. Quantum circuits are being embedded in traditional AI pipelines, and I will be happy to tell you more about that separate conversations with the help and support of my technical colleagues, really to let you have the real view of how we are believing in this and how we are working on this. How these quantum circuits considered and treated in this way can help us, allowing us to explore problems from new perspectives. With the current quantum computing, really we are exploring how we can continue to understand more and better. What comes next? We don't know yet. I mean, the vision is we can have really great results. Maybe we can have a failure, but what we need to do is really going on in integrating this quantum sensing, quantum communication, and computing across every layer of Earth observation pipeline. Okay, and in fact, okay, this repeat what I was saying in theory, just to give you, to tell you that we really created this QC4EO. So we've had, and who worked with us in the past knows, we have the real revolution from AI for EO. It's already many years that we had that, and now it's a fact, and now it's a sector also used from everyone else. We passed from AI for EO to QC for EO. We have had, and we still have a lot of collaboration with the main actors of this field from academia point of view, from industries, and so on. And we do together, we explore this together to advance it and to understand and to address the computationally demanding Earth observation problems. So we'll see where we will arrive, and I hope that we really can do Sabrina, that together.
Sabrina, we have a problem with the presentation. We can't see it now. It's all black.
Oh, you cannot see the. Oh, sorry. You cannot see the presentation anymore.
No, it's black. No.
Oh. Okay.
Maybe you can stop the.
Still blocked. I don't know what happened. I mean, I didn't do anything, I hope.
Yeah, we can see the number of the slide, but we don't see anything.
Okay, maybe if you can just stop, I can stop sharing for a moment.
Yeah, stop sharing and share it again.
And then I do it again.
Yeah.
So let's try this. And now maybe you see me. Do you see me?
Yes.
Okay. Hello, everyone. Okay, now share. I try again. Okay. Okay, I try to resume from slide where I arrived. Let's see if it works like this.
Yeah, we can see now.
Does it work now?
Yes.
Good. Okay. And so, well, the interruption was at the right moment because we went from PhilLab Explore Office to the PhilLab Invest Office. I hope that this will be, I will go very fast on that, and I hope it will be useful and interesting for you too, even if the focus will be more on the commercial side. But I think it's important because all that we said, I mean, can also inspire some of you to experiment all this and go on the market, because at the end of the day, we need not only research on these applications, but also results like products, like services, something that can help the community. So, Invest Office is the other office that we have inside the PhilLab, where we stimulate the competitiveness, we foster entrepreneurship, commercial initiatives, and we try to help the growth of the space economy inside the member states. How we do that? We do focusing naturally only on Earth observation, because we are in the Directorate of Earth Observation, and because we understood, also with the help and support of the Explorer side, that if we combine space, Earth observation with all the other aspects that we've talked so far, we can really help and serve the market in every domain. I mean, when we talk of Earth observation and Earth observation market and commercial activities, we have the final customers that are totally different from space, can be totally different from space and Earth observation, because we affect agriculture, healthcare, transport, financial, aviation, media, whatever. So how do we help the industries, startups, and the commercial community in that? We manage one of the biggest commercial program of ESA, which is Incubed. Don't be misled by the word. Incubed does not stand for incubator, but stands for investing in industrial innovation. So Incubed is incubed with the three, Incubed. And is the biggest, I think I can say the biggest commercial program of ESA, a co-financing program open to all the member states who subscribed it. Spain did, I can tell you that. And what we do is really support startups, but not only, big industries, SMEs, research centers who have more than an idea, but a real strategic idea, let's call it like this, to bring on the market where Earth observation and innovation is the focus. So, well, we see it better like this. What it is, it's an industry-led commercial program focused on develop Earth observation, innovative and commercially, products and services. The scope can be anything. We help the industries to really build the satellites from scratch. We helped to create software, applications, apps, innovative business models to help whoever final customer can benefit from that. It's an open call and can co-finance up to 80% for the startups and research centers, assumed that the other part, so the industry part or the research center part, can back up the other 20% or 50%, because in general we co-fund 50%. But if you are a startup to apply, we arrive up to 80%. Why I said before not a very new idea. Okay, maybe it's too far, this slide is too small, the details, but I just wanted to give you a few hints, and you are more than welcome to go on the Incubed website or to reach out to know more if you are interested. What we do, we encourage the startups to apply with a simple pitch whenever they have something that they want support to bring on the market. The startup must be constituted, so we do not, okay, if it is at an early point, we also push for the de-risking phase, but really the startup must have a business plan, must have a kind of solidity to go on, to move forward. As I said, there is a very simple process to apply, a very simple pitch as a first step to pitch their ideas, and if we find it interesting, we even support the startup also to eventually fill in gaps or problems. So we accompany the startup to the second phase, which is the application of the submission of the first draft proposal. And then the process continues until the submission of the final proposal. After that, if everything works fine, we sign the contract. We do not have real limit. We can finance up to 1 million or even more. As I said, we co-finance the construction and the launch of a real satellite. For Spain, the process, because all these being an optional program of ESA, the delegation, so the national delegation must be involved in the process. And if I am not wrong, for Spain, it works the other way around with respect, for instance, to Italy, because while in Italy the startup goes with the application, the submission of the proposal, and at the end, if we think that the proposal is worthy and we want to sign the contract, we involve the national delegation. I think that in Spain works the other way around. And if I'm not wrong, just a few weeks ago or a few days ago, the national delegation in Spain launched the call for Incubed. So I hope that I'm giving you correct information. I'm also confident that no one online will tell me that I'm wrong, but I'm almost sure that it is like this.
Sabrina, we have 2 minutes. Okay? We have 2 minutes to go.
Oh yeah, it's finished. Okay, so we are. Okay, the process how apply, I said it. The call will be from your national delegation. This is a slide just to let you see how many PhilAb-powered satellites and constellations we have in orbit now. So, forever, if you have an idea to go on the market where Earth observation and innovation are there, please reach out because you can use Incubed. And that's it. Perfectly on time, I hope. I thank you. I thank you very much for your attention. I don't know if we have time for questions, maybe not, but I really am totally available for...
Okay, Sabrina, thank you for... Yeah, can you hear me? Yes. So thank you for your presentation. I'm sorry that we don't have time for questions because we are just on time to start with the next part of the event. So
no problem. I'm sorry if I get too long. I mean, it was structured for enough.
It was a great presentation. Thank you, Sabrina, and see you in another event.
Thank you. Thank you very much. And I will share the presentation later on, maybe at the end of the event, so that if someone wants to reach out. I thank you again for the opportunity to be with you, even if remotely. And I wish you the best for the continuation of the event. Bye-bye, everyone.
Thank you, Sabrina. Bye-bye.
Thank you. Bye. Adios. Thank you.